Next example again says write as a single logarithm. This is the same idea as simplifying, which means we are going to look at the right-hand side of those formulas and see if we can write them as the left-hand side. We want to get a single logarithm in the end. Now, log laws are very, very, very particular. And by what I mean by very, 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 very particular is the first log law that has adding says log a of m plus log a of n. There are no numbers in front of the log. In fact, you can only use that log law if you have one log plus one log. Can you see in our example, we have one log plus three logs. We are not able to use log law number one because of that 3. But is there something we could do with that 3? Yes. Log law number 3 says if you have a number out in front of a logarithm, you can move that inside the logarithm as an exponent. So I can rewrite this, and I would have to do this first. I can move that 3 in as an exponent. And now I have 1 log plus 1 log, and I'm able to use my first log law and say, if you're adding 2 logarithms, you can combine those together by multiplying inside the logarithm. So for part B, we're going to realize the same thing. Before we can add or subtract, the first thing we're always going to do, if we're combining as a single logarithm, is move numbers out in front in as exponents. So this second example, I have a log plus a log minus a log, but first of all, I'm going to take each of those numbers out in front. And put them in as exponents. And next, I'm going to show you a shortcut that's going to save you some time. If you are adding and subtracting a bunch of single logarithms, and by single logarithms, I mean they all have 1s in front, right? We don't have any numbers in front anymore. We've moved those in as exponents. If you are adding and subtracting a bunch of them, you can use the following shortcut. Anything that is added, well, that's going to get multiplied together, because that's your log law, and it will be in your numerator. And anything that is subtracting, well, that's dividing, so that will be in your denominator. So you can do that all in one step. Alternatively, you could show this in 2 steps. Can you see that you could have put these 2 together first and got a single log xy squared? And then you'd still be subtracting the logs that before, and then next you'd have to divide and get this as a final answer. Okay? But I'm going to encourage you to do it all in one step, because you might get some that look like this. Here, we'll do. We're going to add an extra example. We'll call it B.5. Perfect. It's the letter that's in between B and C. So, I want you to write as a single logarithm the following. Log A plus log B squared minus log C to the 5 plus log D cubed minus log of F to the 4. I already put the exponents in so we could save ourselves a step. Can you see that's a bunch of single logarithms all added and subtracted? So the shortcut would say whichever ones are added, the A, the B squared, and the D cubed, they will all go together in the numerator. And whichever ones are subtracted, which is the C to the 5 and the F to the 4, they will go in your denominator. And that's such an easy shortcut and will save you so much time that it is really, really helpful. Now part C, we want to write as a single logarithm, and we have log 2 of 6 minus 3. But unfortunately, the 3 is a number. You can only use subtracting log law if you have a log minus a log. So what we're going to do with this one, put a blue box around this 3 and say, is there a way that I could write the 3 as a log with the same base of 2, but something in here? Is that possible? Can you do that mental math? What number goes in the box so that that blue log 2 of something is equal to 3? I'm looking around. There's people that are giving me the eye thing, and I know you're gonna, like, if I ask you, you're gonna do. Oh, sorry. What was the question? Nice. Yes, it is 8. 3 is equal to log 2 of 8, and if I rewrite the 3 as a log, now I can use a log law. Log 2 of 6 minus log 2 of 8 would be log 2 of 6 divided by 8. Which beautifully is the same as, well, not beautifully, it's just simple reduction, right? Log 3 of 4. But then you can, like, logs you can play around with, and you can get things that are equal that you would never expect to be equal. For example, if I gave this to you as a multiple choice on a non-calculator part of the test, you would be mad at me, but I'll show you what I could possibly come up with. I could say the following question: log 2 of 6 minus 3 is equal to, and then I could have a bunch of different answers possible, and one of them would be log 2 of 3 minus 2. And this would be an example of a multiple choice question. If it was on a test, you would probably look at all the answers and go, I have no idea, I will guess. Right? Some of you have been there on multiple choice questions many times in your life. I have no idea, so I will guess. They used to make some multiple choice test questions where if you got an answer wrong, you actually lost a mark. You got 2 marks if you got one right, but you lost a mark if you got it wrong. What were they trying to do? Trying to stop people from guessing. If you left it blank, you didn't lose any marks. But if you guessed and you guessed wrong, would that totally change your strategy in multiple choice? Ooh. I've even seen some math contests, some of you are in math contests. They do the similar thing, but they're like, if you get it right, we'll give you 5 points. If you get it wrong, we'll give you 0. If you leave it blank, we'll give you 2 points. What are they trying to do? Get you to do? Not guess, right? If you have no idea, you're like, I'll leave it blank. At least I get 2 points. Which is the same as losing a point when you get it wrong, but that just seems harsh. Maybe I'll do that on your next. Well, you can't get 100 because you get, each one is worth 5 points. So if you leave it blank, you only get 2 and 5. You're still only getting 40% if you leave it blank. Okay, why is this equal? Because I can now play around with my log laws on this one and say if I'm dividing is the same as subtracting with the same base. And this would be the same as log 2 of 3, and 2 to what exponent is 4? That's equal to 2. So you can play around with logarithms and change what they look like, but still have the same answer. questions for practice on this one are 5, 8, 11, and 18. And at this point, I want to look at the question or the thing that I wrote at the beginning, and I want to see if you can see how it works. Right? At the beginning, we had this, and I said it's equal to 3. How could I possibly do that with mental math? Well, maybe now you can see that if you're adding two logarithms, that's the same as multiplying. And 8 times 27 is 216. And 216 is 6 cubed, so the answer to this would be perfect. But hard to see that. Okay? Maybe easier to see that if you think of the 8 as 2 times 2 times 2, and the 27 as 3 times 3 times 3, then you've got 6 3 times. Works out nice.